Let's continue working with similar polygons. So we'll cover a few different examples. So this first one says write a similarity statement. So you need to understand what exactly your answer is supposed to look like. A similarity statement. And for that, that's like when we said triangle ABC is similar to triangle DEF. That's a similarity statement. So in this case, we have two quadrilaterals, and we just need to figure out what matches up with what. Now sometimes the pictures are drawn so their orientation is the same, but sometimes one might be flipped or rotated a little bit, so you have to look at the markings to figure this out. So what I'm going to look at, I'll start with the polygon, the quadrilateral on the left, and pick any point you want. I'll pick A, since logical, alphabetical, we'll call it ABCD. Now A has a single mark, and so we have to find the single mark over in the other polygon, which is L. So you can write the first one any way you like. So I'm going to write ABCD. Somebody else could have said, oh, I want to start with C and go counterclockwise. I want to do C, B, A, D. And that would be fine. Somebody else might say, oh, I want to do D, B, A, C. That would not be fine. Why isn't that fine? Because if you start with D, you can't jump across. You either have to go clockwise or you have to go counterclockwise. So you can't just list any four letters in any order you want. You pick one to start with and then go either clockwise or counterclockwise. All right, so I'm going to go with, excuse me, A, B, C, D. So there's more than one correct answer on this. So once I decide to do that, so A, B, C, D is similar to, and now here's where I have to make sure I match things up. So A matches up with L, so that's going to start the second one. And then I'm looking at B. B has this double mark, so that would be E. And then I look at C. C has this mark here that matches with H. And then obviously P would be the last one. So ABCD is similar to LEHP. Somebody else might have decided that they want to do CBAD, like I mentioned earlier. And if that's the case, then their answer is going to be HELP. Okay, and so there's more than one correct answer. All you have to do is list one of them, not all of them. All right, so here's another problem. Are these two triangles similar? Well, the first thing you need to remember, if polygons are similar, their corresponding angles have to be congruent. Let me write this over here. Angles congruent, corresponding angles congruent, and the corresponding sides don't have to be congruent, they have to be proportional. So we're going to have to set up ratios. But the first thing we want to check are the angles. And so when we look at this, we don't have all three angles in the triangle. This one has an 80 and a 45. This has a 45 and a 55. So we have to figure out the missing angles. So 180 minus these two will give us this. So let's do that first. That's 100, and then minus 45 gives us 55. So this angle here is 55 degrees. Likewise, if you check the other triangle, 55, 45, that adds up to 100. So this has to be 80. So the first thing we check is that the angles match up, and they do. We've got all three corresponding angles congruent. So that's taken care of. So now what we need to do is check the sides. Now here's where we have to be careful. So which sides do we match up? Well, I usually start with the smallest side. So in this triangle, the smallest side is a 2. That's going to have to match up with the smallest side in the other triangle. Obviously, it would have to match up with the 4. So that's the first ratio I'm going to write. 2 over 4. Okay, and so now I'll pick the next biggest side, which is 3, and the second biggest side here would be 6. So does that equal 3 over 6? And does that equal the last two sides, 5.5 over 11? Now, you really don't probably need a calculator to figure this out, but all these fractions reduce down to 1/2, or 0.5. And so therefore, all of these are equal, so the sides are proportional, so yes, these two triangles are similar. So that's what you need to do. Now, if it wasn't so easy to look at these fractions and tell if they were congruent to each other, you can just grab your calculator and divide them. 2 divided by 4 and write down the decimal. 3 divided by 6, 5.5 divided by 11. And if you get the same decimal for all three, not 2 out of the 3, but all 3, then that means the sides are proportional, and then the angles were congruent, so it's a yes. Let's look at another example. We've spent a lot of time solving proportions, and so I'll just go through this quickly. We're going to cross multiply. So 7 times 24 equals 21 times x. And then we would divide both sides by 21. And we're going to get x equals 8. You can check that on the calculator. Now there is a shortcut sometimes. I noticed when I looked at these numbers that 7 times 3 equals 21. So what times 3 would equal 24? 8. Doesn't always work, but sometimes it's a nice shortcut for you. That doesn't work in this case because 12 times what is 27? That's not a integer answer, so maybe you're going to have to multiply this out. Now I'm actually not going to cross multiply first because I can actually reduce these. I noticed that 9 goes into 18 twice and 9 goes into 27 3 times. Now I actually do see a relationship between these numbers. If I multiply 3 times 4, I get 12. So if I multiply 2 times 4, I get 8, which means x plus 2 has to equal 8. And therefore, x is equal to 6. So you can save yourself a little bit of time. But if that was too confusing, just go ahead and cross multiply like you normally would. So x plus 2 times 27 equals 12 times 18. And then you distribute the 27, and then you solve the equation. And eventually, though, you will get to x equals 6. All right, let's look at another example. Find the length of the missing side. Now, when you first look at this, you might think, okay, I'm just going to match up 5 with x and 4 with 10. Unfortunately, there's no information here that's telling us these two triangles are similar. So technically, right off the bat, you could look at this and say there's not enough information to solve this. All right. So I want you to keep that in mind because sometimes on worksheets they don't really have enough information. They're not clear enough, and so you're really not sure how to set this up. On the other hand, let's say that they did tell us the triangles are similar. Triangles similar. That's still not quite enough information because how do I know the 4 matches up with the 10 and the 5 with the x? It looks like it does, but maybe the 4 matches up with the x and the 5 with the 10. So they really have to give you some other information in order to figure this out. So let's assume that these pictures are drawn so they're oriented the same way. If that's the case, so if all that is known, then you can say 5 over x equals 4 over 10. That's one way to set it up. And there's a lot of different proportions. Somebody else might look at it, and it's very visual, by the way. So 5 over x equals 4 over 10. We could also have said x over 5 equals 10 over 4. What you can't do is, you can't start with one triangle and say x over 5, and then start with the other triangle first and say 4 over 10. So you have to be consistent in your pattern on how you're doing this. You could say 5 over 4 equals x over 10. That should also work. Let me write that down. We could say 10 over 4 equals what? X over 5. That would be valid. We could say, how about 4 over 10? That would have to equal 5 over x. Okay? But notice, in all these different possibilities, when you cross multiply, 5 times 10 equals 4 times x. 5 times 10 equals 4 times x. 5 times 10 equals 4 times x. 5 times 10 equals, 4 times x. So there's a lot of different ways to set it up, but if you've done it correctly, it doesn't matter which way you've set it up, you're going to get the same answer. So when I cross multiply, 5 times 10 is 50, and then equals 4 times x, and then divide both sides by 4. 4 doesn't go into 50 evenly, but it does go 12.5 times. And there's your solution. All right. The assignment for today, worksheet 2, similar polygons.